Greetings, folks. Today, we will be conducting a comprehensive analysis of GitHub Actions, an integral component of GitHub's built-in CI/CD platform. GitHub Actions is a powerful continuous integration and continuous delivery CI/CD platform that allows users to automate various aspects of the software development lifecycle, such as building, testing, and deploying code. It integrates seamlessly with GitHub repositories, providing a streamlined approach to automating workflows directly within the platform. The key components of GitHub Actions include workflows, events, jobs, and actions, which are defined using YAML files and triggered by specific activities within a repository. Runners, available on multiple operating systems such as Linux, Mac OS, and Windows, execute these workflows, allowing for diverse development and deployment environments. GitHub Actions supports a broad range of programming languages, including Node.js, Python, Java, Ruby, PHP, Go, Rust, and .NET, making it suitable for many types of projects. The platform is widely used for CI/CD purposes, automating repetitive tasks like issue labeling and managing pull requests, which reduces manual intervention, ensures consistent processes, and enhances scalability when handling complex workflows. This automation results in more efficient and reliable software delivery, making GitHub Actions an essential tool for modern DevOps practices. What makes GitHub Actions such a powerful tool for developers? Well, it's all about its key features. GitHub Actions offers automation workflows that can automate tasks like CI/CD, testing, and notifications, making life a lot easier. It also supports custom actions, which means developers can create reusable pieces of code to combine in workflows, enhancing productivity. Being event-driven is another advantage, as it allows workflows to be triggered by various events, such as commits or pull requests. Plus, the broad ecosystem support makes it versatile, providing compatibility across different languages, tools, and operating systems, enabling seamless integration into a wide range of projects. Why is GitHub Actions so important for developers and teams? Simply put, it's because of the benefits it brings. Enhancing productivity is one of the key aspects. By automating repetitive tasks, developers can focus more on coding rather than manual processes. It also offers seamless integration since it's built right into GitHub, making it super easy to set up and use. Encouraging collaboration is another highlight, as it supports multi-stage workflows that enable teams to work together more effectively. Lastly, the scalability and flexibility of GitHub Actions allows it to handle complex workflows and integrate seamlessly with various third-party tools, making it suitable for both small projects and large-scale operations. What are some of the major advantages of using GitHub Actions? To start with, it offers built-in GitHub integration, meaning there's no need for external CI/CD tools, which makes the setup smoother. The customization and flexibility is another big plus. You can create workflows tailored to your specific project requirements. Then there are reusable components. Actions can be reused across multiple workflows, which helps with code efficiency and standardization. Its event-driven model is perfect for automatically triggering workflows based on specific events, ensuring a hands-off approach. Lastly, it's free for open-source projects, making it highly cost-effective, especially for public repositories and collaborative open-source initiatives. Are there any downsides to using GitHub Actions? While there are some challenges, they're mostly insignificant once you get used to it. For instance, there's a learning curve. You need to understand YAML syntax and GitHub's workflow structure. But honestly, this is just a matter of time. Once you get the hang of it, this challenge fades away. There are also resource limitations, where usage limits might require extra costs for bigger projects or private repos, and limited cross-repository support, which can make managing complex workflows across multiple repos a bit challenging. Lastly, configuration complexity can be an issue, especially when dealing with more intricate workflows. However, once you grow comfortable with the setup, these limitations become manageable and less daunting. What are the main use cases for GitHub Actions? There are quite a few, and they cover a wide spectrum of needs. CI/CD pipelines are a big one. GitHub Actions helps automate testing, building, and deployment processes seamlessly. It also excels in automated testing, allowing you to run unit, integration, and end-to-end tests automatically. Code quality checks are another common use case, where GitHub Actions can take care of code linting, security scans, and overall quality control. For teams managing product releases, it can handle release management, helping with versioning, tagging, and automating the release process. And finally, it supports DevOps workflows, which include infrastructure as code, configuration management, and monitoring, making it a versatile tool for various stages of the software development lifecycle. What are the key takeaways about GitHub Actions? To sum it up, GitHub Actions is a powerful, integrated CI/CD tool tailored for GitHub repositories, offering deep integration and convenience. The benefits include seamless integration, flexibility, and event-driven automation, making it a highly effective tool for managing workflows. Of course, there are some limitations, such as a learning curve, potential resource costs, and complex configurations for larger projects, but these are usually overcome with experience. Finally, the use case versatility of GitHub Actions makes it highly effective for various automation needs, including CI/CD, testing, and broader DevOps automation practices, proving its value across the development lifecycle. Alright everyone, before we dive into the magic of automation, let me ask you, what are the two essentials you need to get started? Yup, you guessed it, an AWS account and a GitHub account. So, let's start with the AWS account. Now, if you don't already have one, don't worry, setting it up is a breeze. Just head over to aws.amazon.com, click that big Create an Account button, and follow the steps. What do you need? Just an email, a password, and a little patience while AWS sets things up. It's like getting the keys to your own cloud playground where we're going to build, automate, and scale some seriously cool projects. And yes, AWS will ask for some billing information, but don't panic, there's a generous free tier to help you get started without stressing about costs. Now, once you've got your AWS account ready, here's the next step. You're probably wondering, what's next? Let's jump into setting up some permissions. On the AWS homepage, navigate to IAM. Why IAM, you ask? Because this is where we manage users and their access. Go ahead and create a new user, let's call it GitHub Actions. For simplicity, we're giving this user administrator access. I know, it's not best practice, but for the sake of this tutorial, we'll keep it straightforward. Once you've created the user, you'll see it appear in the user list. Click on that user, head over to Security Credentials, and find Access Keys. Create an access key, and boom, you now have an AWS access key and secret access key. Keep these safe and private, don't share them with anyone. Alright, now let's move over to GitHub. I've already created a repository called AWS Data Engineering, but if you haven't yet, take a moment to set one up. Ready? Great. Navigate to Settings, then Secrets and Variables, and select Actions. Click on New Repository Secret. Now, here's the important part, you'll create keys with the names AWS_access_key_ID and AWS_secret_access_key and paste in the values from the AWS IAM page. I am using PyCharm for this demonstration, however, you are free to use any integrated development environment, IDE, that suits your workflow or preference. Let's examine this folder directory. This directory structure is necessary for GitHub Actions to work correctly. Specifically, the .github/workflows folder must contain your workflow YAML files. For example, deploy GitHub Actions test.yaml, as GitHub Actions requires this exact structure to identify and run workflows automatically. Without placing workflow files in .github/workflows, GitHub will not detect or trigger the workflows. Other folders, like GitHub Actions Test, are optional and can be organized based on your project's needs. This GitHub Actions workflow is designed to automate the deployment of an AWS CloudFormation stack upon the submission of changes to the master branch of a repository. The workflow is initiated when modifications are pushed to the master branch. It executes on the Ubuntu latest virtual environment provided by GitHub Actions, comprising 3 fundamental steps: repository checkout, AWS credentials configuration, and CloudFormation stack deployment. Initially, the workflow employs the action/checkout at v4 action to clone the repository code into the workflow runner, ensuring the availability of all files required for deployment. Subsequently, it utilizes the AWS action/configure AWS credentials at v2 action to securely establish AWS credentials, thereby enabling interaction with AWS services. It is imperative that these credentials possess sufficient permissions to execute the deployment effectively. The workflow operates within the App Southeast 3, Jakarta, AWS region. The final step involves deploying the CloudFormation stack defined in GitHub Actions test/stack.yaml using the AWS CloudFormation deploy command. The stack is designated as JFNG7K, and the capabilities flag is specified with capability_IAM and capability_named_IAM to grant the necessary permissions for the creation or modification of IAM resources. In conclusion, this workflow provides an automated mechanism for deploying AWS infrastructure in response to changes committed to the master branch. It encompasses secure credentials configuration, repository checkout, and the deployment of the specified CloudFormation stack, thereby streamlining the continuous integration and deployment process. CloudFormation is an infrastructure as code (IAC) service provided by Amazon Web Services (AWS) that allows you to model and set up your AWS resources in a programmatic, automated, and repeatable manner. Instead of manually configuring resources in the AWS Management Console, CloudFormation enables users to define resources using templates written in JSON or YAML. These templates define the desired state of AWS infrastructure, making it easy to manage, replicate, and track changes to the resources. It significantly helps organizations streamline the setup, reduce the risk of manual errors, and ensure consistent configuration across environments. The given CloudFormation template is a simple and effective script for creating an Amazon S3 bucket. S3, or Simple Storage Service, is AWS's scalable storage service commonly used for storing files, logs, backups, and data lakes. This template allows users to generate an S3 bucket with a unique name, customized by providing the project name as a parameter. The template uses the specified project name along with the stack name to ensure that the bucket name remains unique, which is a key requirement for S3 buckets globally within AWS. The Parameters section defines a single parameter, project name. Parameters allow the user to customize the template when creating a stack. In this case, project name helps uniquely identify resources created by the stack. It must follow a pattern that permits only alphanumeric characters and hyphens, which ensures that the bucket name adheres to S3 bucket naming rules. The parameter has a default value, random bucket name, which can be overridden when creating the CloudFormation stack, allowing flexibility and reusability across projects. In the Resources section, an S3 bucket name subbucket is defined. The Properties subsection specifies a bucket name that is dynamically created using the combination of the project name, $project name, and the stack name, $AWS stack name, using the !sub-intrinsic function. This ensures that the bucket name is unique across AWS by adding a contextual element, stack name, to it. Tags are also added to the S3 bucket, which helps organize and manage AWS resources by allowing additional metadata to be associated with the bucket, in this case using project name as the key. Lastly, the Output section provides information that users might want after creating the stack. The output includes the bucket name and bucket ARN, Amazon resource name, which are both critical pieces of information that users might need for further integration or reference. By providing these outputs, users can easily capture key identifiers for the S3 bucket without manually navigating through the AWS console. This helps in building more automated workflows by integrating these output values into other scripts or tools, thus maintaining efficiency and simplifying post-deployment tasks. Now navigate back to GitHub. Select GitHub Actions. You will see that the commit that was just pushed is being processed by GitHub Actions. I must have made several attempts before. Please make sure the screen you are facing is the same as what I experienced. If the deployment process to AWS is successful, then you will get a green check mark, but if it fails, then you will get a red cross. This screen is a proof that the GitHub Actions configuration is successful. Navigate back to AWS CloudFormation. Select Jakarta region. Navigate to Resources. You will be given a link to the resource that has been created, in this case S3 bucket. Click this link. Congratulations, your S3 bucket has been successfully created using CloudFormation with GitHub Actions. Okay, now I want to create 2 S3 buckets. The steps are easy. I just copy the S3 bucket creation syntax above. Be careful, the S3 bucket name cannot be the same. The resource name and the CloudFormation template cannot be the same either. Okay, we commit, and we monitor AWS CloudFormation. You can see that CloudFormation is being updated. This is indicated by the status which was originally completed to update in progress. Wait a few moments, then we will see the results. Okay, the status changes again from update in progress to update completed. Voila, you have successfully created two S3 buckets. What if we want to delete an S3 bucket? The method is the same, namely we delete the previous syntax from the CloudFormation template. Then we commit and push again. Wait a few moments. Yay, you have successfully deleted one by one S3 bucket. That's my YouTube tutorial. Hopefully it is useful. Don't forget to click like and subscribe. See you on another occasion.